Okay, hello everyone, and welcome to another episode. So we are doing the Knative series, and those of you who are new to the channel, my name is Sayam Pathak. I'm a CNCF ambassador working as Director of Technical Evangelism at Civo, building the next gen cloud platform. And I do regular streams with awesome people like you can see yourself on the screen, including myself. So we do regular streams on different cloud native technologies so that we all learn together. So make sure you subscribe to the channel if you are visiting for the first time. And if you're watching on Twitch, then make sure you follow there as well, because that keeps me, keep going with all the stuff. So let me just switch this on and this off. Cool. Um, so very excited for this one. This is the fourth session in the Knative series. So we have been doing Knative series where we started from the origin and the governance. Then we moved to Knative 101, where we discussed briefly about serving and eventing and how to set up Knative on a Kubernetes cluster. And then we moved towards the serving deep dive with an amazing demo that everybody just loved. And we'll be just making that a default kind of demo for auto scaling, because that was really cool. And today we'll be discussing all about eventing, and we'll go deep dive into eventing. And very glad to have Ahmed with me today. So that will be very interesting to see, go over the deep dive concepts on eventing, and there's a lot of things that Ahmed has shown me. So it'll be really cool today. And we'll be doing the similar way. So hi Gyan and all of those. Hi Neol, Leon, Rashmi. So very glad to see you all here. And please make sure you create the Twitter threads. You can see our Twitter handles on the screen. So make sure you create the Twitter threads and tell us what what you have learned, because I have heard the exact same feedback from the Knative team that they have loved the Twitter threads that you have been creating on the things that you have learned from the stream and what you will be doing next. So that's pretty awesome. So keep doing that. And today, I'll be picking one winner in the end, who have created the best Twitter threads over the past 4 streams, because you have been consistent, and I also always want to give back in some way. So I'll be doing that. And with that, we can get started. So Ahmed, welcome to the stream, and so glad to have you today. Please introduce yourself to the community.
Thank you very much. Very glad to be here. Hi, my name is Ahmed Abdullah. I'm working at Red Hat in the OpenShift serverless team. Specifically, I'm focused on Knative eventing, and in the community, I'm the execution working group lead with the rest of my colleagues. A lot of them actually I would have really loved to join me today, but due to different arrangements and vacations and stuff like that, we didn't really make it, and they would have known a lot more about these stuff than me anyway. So I hope I give eventing its due. It's a big shoes to fill. So very glad to be with you guys.
Awesome. So glad to have you. So if you have not seen the past videos of Knative, so what I have done is I have put all the 4 videos in a playlist that I'm just sharing right now with you all. So this particular playlist is consists of all 4 of the streams. Simply I just added them to playlist I'm sharing with you, so that you can just find them under one hood. So make sure you watch those, because those are really good. And the knative.dev is the website which clearly explains most of the concepts, and very straightforward to follow. If you want to install Knative on Kubernetes cluster, I did on Civo Kubernetes when Carlos was just talking. So I mean that it's that simple. So it's nothing rocket science over there, and you get a lot of features, auto TLS, directly getting from your container image to the service URL. So basically you get all of this thing, all of those particular things. And today we'll be talking about eventing. So Ahmed, how do we want to get started? You want to share some fancy slides?
Yeah, exactly. Today, it will be like a mix between some presentation style for some topics and concepts, and we're going to be building an event-driven application. It's a simple one to basically explain how does the Knative in general and the Knative eventing specifically help you build such applications. And I'm trying to take it in a problem-driven way. parts of the stream will be like brainstorming more or less, and going a lot to the whiteboard, where we will discuss some of the design concepts and design choices that we have, so that it's also clear for you folks what does different building components in eventing solve for you, basically, and how do they differ from each other.
Cool.
So yeah, I can start by sharing my screen, and please, if at any time you have questions, feel free to shoot them. I apologize that I can't keep an eye all the time on the comments. I'm actually on vacation, and then I don't have my external screen, so it's gonna be hard for me to switch to the comments, but Siam is gonna help me there. So feel free to ask at any point.
Absolutely.
Let me share my screen. I'm gonna
Yep.
be sharing.
So community, please keep sharing your questions as and when the stream is progressing, because that is important. That's what makes it more interesting.
So I hope right now you can see the full screen of the slides.
Yep.
All right. Yeah. Basically, I wanted to start with a recap about what is Knative eventing, and the whole domain of eventing is very, very complex. So there are a lot of technologies out there and a vast number of use cases. So to simplify what eventing is, I like to think of it as it's an opinionated way of building event-driven applications or event-driven architecture solutions using Kubernetes for Kubernetes native applications, for people who are familiar with Kubernetes, following the design concepts of Kubernetes itself. Kubernetes gives you a declarative APIs, as you folks know, and this is one of the design principles that Knative in general is following, and eventing is giving you a similar style of APIs, and following the similar declarative way of specifying the desired state, which is represented in most Kubernetes objects in the specs, and having controllers and reconcilers that are reactive, that try to reach with the current status to the desired status, basically. And this is the general specs and status fields that you see in a lot of Kubernetes objects. Eventing tries to give you a set of building blocks that you solve different categories of problems that are pretty common when you try to build event-driven architecture or event-driven applications. And this is the style that we will follow today, going across these different problems. If you also check whether the documentations, the specs, the first session of Knative, where Vile, one of the co-founders of the project, is discussing the design, also principles of Knative, you will see that eventing specifically tries to focus on providing a set of independent and loosely coupled producers and consumers. That means that you can create consumers before there are actual producers, and vice versa. You can create event producers before there are actual consumers. And they try to be as decoupled as possible, in the sense that they don't necessarily strictly know about each other, or the 100% of the nature of each other. And we will understand more about that as we go on. Also, eventing tries to standardize on the format of the events and some of the aspects of the APIs. And this is specifically done to help solving problem like an interop problem, like when you're trying to, especially in eventing, where it's a very famous technology or approach or architecture for solving integration problems between heterogeneous systems. This is a very difficult problem to tackle. So from day one, eventing was opinionated by standardizing on the event format using the CNCF Cloud Events project format. And this helped simplify a lot of the user experience that you will be seeing later and how to solve them using eventing. Also, eventing tries to be neutral as much as possible to the actual technology that is giving you the eventing and the messaging capabilities. So whether it's Kafka, NATS, RabbitMQ, GCP, or whatever, eventing as a set of APIs and building blocks tries to standardize on the API layer and make it free and available for different implementers to make their own decision and opinion about the actual messaging and eventing technology. This is why you can think generally of Knative eventing as an eventing core, which is basically a stable API and a bunch of reference implementations, along with a bunch of useful building blocks that try to stay, as I said, as neutral as possible. This is one aspect, and what complements that for you to build or to use it in a production environment, a real world use case, is the ecosystem of eventing, which we'll touch upon very briefly today. But this is a core part of the ecosystem of Knative eventing as a whole. And if you also want to recap, why do people usually lean for event-driven applications when they try to provide solutions for some problems? You need to understand first what are the main categories of problems that people building event-driven applications face. And the first one of these would be how to get your events. And this is basically event ingressing. Knative eventing solves this by providing a concept of a Knative source. Knative source is basically the component that brings your events into the cluster or produces your cloud events, more or less. In a lot of cases, or a lot of types of sources, they are off-cluster events, but sometimes they are auto-generated. For example, we have a source that, based on a timer or a schedule, generates cloud events. But the idea is that the way that you ingress events into the eventing mesh, if you may think of it, is typically via a Knative source. This is the logical concept that have different concrete implementation that we will touch upon later. The second problem that developers of EDA applications face is the event routing. And how do I route my events? Because there are a set of design problems that you may face, or there are a set of constraints that you need to optimize between. Because at the end of the day, you definitely can just write an all-in-one application. However, as we all know, this is not a typical way implementing it, because you'll face problems about extensibility, maintenance, etc., etc. So the main solution or building block that Knative eventing provides are the broker and the channel. And we will go in details into the differences between these two. But they are basically your way or Knative way of routing events in different styles, if you may. Broker is a content-based routing, and channel is a topology-based routing. And as I said, we will dive into that later. This is where you take your event and basically push it and or route it to your desired destination. And the third kind of problems that event-driven application developers usually face is, how do I egress my events? How do I take events that are inside my cluster and or inside my system and send it to an external destination? And the logical concept that eventing tries to provide there is called a sink. Again, this is an abstract concept, just like a source is. There are different kind of concrete implementations, but think of a sink as a destination that takes a cloud event and takes it to the final off-cluster system, basically. I hope this generally gives you an idea about what kind of problems Knative eventing generally tries to address in different components. So what about the use case? Also, if there are questions, I'm happy to answer. If I'm also a bit fast, please slow me down anytime.
All going awesome. So, and no questions so far.
Great. So a lot of time I get questions from people discussing what exactly event-driven architecture are useful for. Sometimes it's very natural or normal to understand these things as a concept, but when you're especially with people who are unfamiliar with event-driven applications, there is a different ways to solve basically the same problems. So it's hard to understand exactly why do I need to use that. And I like to focus on two concrete use cases that really show what is the use of or the power of following an event-driven application. The first use case is the extensibility problem. And think of this, that I have a system, whether I own that system or it's an external system or it's a legacy application that I don't want to touch, or that the cost of changing or modifying that legacy application is going to be huge. And I would like to extend the functionality of that system. I would like to add some new features without touching that system. This is where the power of event-driven architecture happens. And basically, I do that by providing a set of extensions, whether as microservices or it is kind of like the poster child use case for fast or for serverless, by providing a function or a set of functions that add and extend the feature set of said application via reacting to a set of events and responding via a set of events with the system that I would like to extend. If you have a GitHub, for example, repo, GitHub gives you the ability to add your own features or add your own functionality that GitHub itself does not provide by responding and communicating with GitHub via events, basically, and via the API for sure. This is why if you have GitHub and you have a source that ingresses the events that are coming from GitHub, and you can use all the features, all the building blocks of eventing that we're talking about, you would be able to extend GitHub without actually touching GitHub itself, as you know. The other problem that is that I also like to showcase that would make that will show you basically the value of event-driven architecture is the integration problem. And basically, you have two heterogeneous applications, solutions. As I said, it can be whether they are in your control or they are out of your control or they are legacy applications. And you would like to integrate between these two, basically add new functionalities that would leverage both systems. Simple solution would be also using GitHub. Can I actually do have some extra features that would also include communicating with Slack? I don't know, like can I check all the comments that probably referencing a set of components in my code base, and if these comments are, I don't know, discussing a specific use cases, notify me on Slack, or vice versa. Can I have Slack-driven interaction with GitHub? Which definitely you will find implementing using a lot of Slack applications. And this is how basically these applications do them. They use GitHub events and the Slack APIs to add these new features. And this is exactly what I'm going to try to, or what we are together going to try to implement today. We're going to try to follow a bit of a problem-based learning. This is the, I really like learning by trying to solve a problem and see what I'm trying to learn, how will it fit these problems, and I thought maybe we can try this today. And what we are trying to focus on is I would like to extend GitHub by adding a moderator. The moderator is a simple feature that as a contributor, if I have a repository, I want to get an email when a negative comment is posted to my GitHub repository issues specifically. Basically, I would like to just, if somebody, I don't know, I'm not that popular, and I see a lot of unpopular opinions in my issues or unpopular features in my project, and I'm unfortunate facing a lot of negative responses. So I would like as quickly as possible to get notified with that on email. So let's try to see how can we solve that. And basically, the first thing that will come in my mind is to build it using a service that would interact with GitHub. It's a very small and a very simple service that you all would probably understand because it's a negative comment analyzer and email sender via GitHub Events service, as you know. So it's a NCAAESVGHE service. And that sounds like a very straightforward way to implement that. However, as you probably know, that this would introduce a huge amount of design constraints. For example, what if I would like to change the logic of how I find out my negative comments? What if I would like to do something else other than sending an email, etc., etc.? So this definitely will not work. So what can we do is the question that we would like to discuss together via the whiteboard. So let me switch to the whiteboard. Are there any questions so far?
Nope, all clear so far, and really looking forward towards the scenario that we're trying to solve.
Cool. All right. So yeah, I'm gonna try this new tool that I'm using. I hope it turns out useful. Basically, we would like to focus on what are the main building blocks that we are trying to do. Would you think that this is an extension or an integration problem that we're trying to solve? Take a quick minute and think about that, which might, look so trivial. Yeah, it's an extension problem. As you know, we are trying to add a feature that maybe it doesn't exist in GitHub, or maybe it does. So basically, what we're trying to do is add to GitHub a new feature. And this feature, we need to try to break it down a little bit, right? If you think from the very beginning, and what is the very first thing you're trying to do? You're trying to communicate or integrate with GitHub. And to do that, you would need, as you all already know probably, to use GitHub events and add your, because we're all building on Kubernetes, add ingress those events into your cluster, correct? Cool. So I would like to have a service that basically have the business logic that I'm concerned with. I'm concerned of, I don't want to, like, if I focus on the first feature or the first component we're gonna use from Knative, I don't like to be concerned very much with GitHub APIs, How do I use them? I don't want to go to the documentation of GitHub clients and the APIs and solve this problem myself, especially if somebody else has already solved it for me. And the answer for that, which probably nobody knows, which we shared 3 times so far, is using GitHub source. The GitHub source is one of the sources that were developed from very early in the project to showcase basically the power of using the concept of sources. So, all right, I'm gonna basically focus first on using a source, and this source will bring me events. And I need to do something. Let's discuss what that thing is. And at the end of the day, I would like to have an email going out. This is more or less like an email with a signature. Yeah, right. This is basically what we're trying to do. So let's not focus on solving everything at the beginning. Let's try to break down this a little bit. Do you have any questions so far? Siam, do you have any comments? Would you like to share something with me before we go back?
No, nothing. I think people are just enjoying the explanation, and they are waiting for how we solve this problem.
Yeah, cool. All right. So we said we're gonna focus on one problem. And as you see, by using a Knative source, our all-in-one service became a little bit smaller. If you noticed, we removed 2 letter because we no longer do via GitHub events. So yeah, we're on the right path. So we have a source. It's gonna shoot some cloud events, and it's gonna send it to a destination. And as we said at the beginning, our destination is called a sink. So GitHub sources is basically the thing that is very common about all GitHub, about all Knative sources, is that they all have sinks, and they all communicate via cloud events. So they all emit cloud events to sinks. And that means basically that from a source to a sink, I need to have a communication destination. And this is the URI, correct? So I need to implement or use a source and tell that source, please connect to whatever source event producer that I have. In our case, this is GitHub. And take all the events and ingress them into this URI. So with a GitHub source, you get a very small and nice Kubernetes object. And the Kubernetes object is basically saying, I have a concrete type, which is a GitHub source. This is the kind. And GitHub source is the concrete implementation of the concept of Knative sources. This source have a name. Yeah, this is just a logical name. And it has a spec, correct? As I said, the spec is the desired state. This is our way of programming our solution. We are saying that based on these whatever, all the configuration that I need from my source, and this is specific and different between every other source. Since we are talking with GitHub, you can expect that we would want to tell GitHub what kind of events we want to ingress into our cluster. And in this case, for example, the sample one is ingressing all the events that are related to pull requests. A pull request was created, assigned, closed, merged, whatever. And this is in this repo. So in a Knative week, eventers endgame. This is the repo that we will try to protect from any negative comments that we have by responding, by not moderating. All right. And this is the key component that we try to integrate with, or that we are going to elaborate more about, which is a URI that I would like to connect to, or that I would like my source to send the events to. So if you would think deeper, How does that look like under the hood? Quick recap about the world of, yeah, it's a general, they are general concepts, but let's try to explain them in Kubernetes world, which is the control plane versus data plane. Control plane is basically the way that you are trying to declare your desired states, the APIs, the API that you use to implement your desired use case. And these basically are the set of controllers that exist in Kubernetes. While the data plane is the set of components that are in the path of the actual data that are live and running in your system. So the typical way, if you create a pod, then you interact with a set of controllers from Kubernetes that schedule the pod and create the actual container. And after that, this is all control plane communication, or this is all control plane interaction. After that, once the pod is live, if you are, for example, communicating with a service, then there is probably some ingress in your cluster, and then there is a node, and the node is routing your traffic to the actual container on the actual correct node. And this is all data plane communication. So you'll see us, especially in eventing, trying to dissect the problems using these two different aspects from now on. How does that look like from a control plane, and how does that look like from a data plane? And let's take that to the board and try to explain it more. So I'm going to switch again, and we're going to clear this thing. Just one second. And since this is a deep dive, I can imagine that some of these under the hood concepts would be not totally relevant for your day-to-day use cases. Basically, every kind of source, more or less, would have a controller, just like any component that is Kubernetes native inside Kubernetes. The controller, in our case, is a GitHub source controller. This is something that you install one time inside your cluster. And the controller reacts to or reconciles all objects that are of kind GitHub source. Once you create that, the controller, it depends on the design. There are different approaches and different designs there. But let's just say that when you install the GitHub source controller and you create an object, you would end up with another pod that is running. And we will just call this pod an adapter. The adapter is the actual component that interacts with GitHub. You're putting here, for example, some information. These information include which GitHub repository, which event types that you want to respond to, etc., etc. So outside the cluster, we have GitHub itself, and the adapter would basically register the actual webhook. So it would use GitHub API to register a webhook, and this webhook would be the one that receives all the events from GitHub itself. All right. Once there is an event, all sources generally need to emit cloud events. So the life cycle of an event is that it reaches the adapter from GitHub. Like, let's say you created a pull request, then you get an event from GitHub, and the adapter makes sure that it sends an actual cloud event to the actual sink. And I'm sorry if this is like mirrored from the other direction, but yeah, this is basically what is happening there. So you can imagine that, let's try to highlight this a bit. let me see if this will work. Yeah, the components that are in yellow, this is all a control plane. This is the one that reacts whenever you create a new object of GitHub source. And the components that are in green, which in this case, the adapter, again, I apologize for the mess. We're gonna keep clearing this a lot. This is basically the data plane. This is where the event path is happening all the time. All the event lifecycle is happening over that adapter. There are a lot of design decisions there. Do I have one adapter per cluster? Do I have an adapter per namespaces? Cluster that are more designed for multi-tenants use cases would tend towards having a different adapter per namespace, while single tenant clusters usually tend to have a single adapter cluster-wide, etc., etc. There are a lot of different implementations of different sources that follow different designs. I hope this is clear so far before we move next.
Yep, I think there is one question, but Carlos has answered that already, and I think you will also explain it when it comes to the workflow part. So basically, when the event is triggered and we get the notification about the negative comment, can we take the action based on that? Like we can delete that particular comment or things like that.
So you definitely can do that. This would be like, I don't an extra feature that you would like to implement, right? You would like to basically communicate back with GitHub using GitHub API and delete this specific comment, for example. This would be like a bi-directional sort of communication.
Yep. So for this particular example that you have, so first we are creating the GitHub source. And GitHub source basically is you have the controller over there, and whenever we create that custom resource of that, then the controller will be creating all those things, will be taking action on that. And we have the adapter. So adapter is the main thing that communicates with with GitHub over here and gets the sort of event that we have defined in the YAML file, YAML spec section. Like in the previous slide, you showed pull request. So it will be, the webhook will be monitoring the pull request. So as soon as there is a pull request, it comes back as a GitHub event to the adapter. Adapter then emits the cloud events, because that's what it is supposed to. All the sources should emit the cloud events to the sink, which is the destination.
Correct. This is exactly how the workflow happens. So you create a GitHub source as a Kubernetes object. The controller reacts, spins up an adapter, configures it, whatever, and the adapter communicates using GitHub API to register a webhook and tell it which kind of events it's interested in. This is where the control plane scenario ends. And then later on, once there is a pull request, the event gets sent to the adapter, and the adapter sends that event as a cloud event to the actual sink.
Okay.
Cool. So let's go back and see how we're going to use that for our moderator. Yeah, let me present first. So as you can see from our design, a very concrete piece of information that we will feed our imaginary service is the URI. We would like to spin up a GitHub source, give it this URI, and do all our implementation of the functionality within this service that we have. However, you can imagine that this is like one of the like a concept that you would try to have is to try to decouple your configuration from your actual implementation and to try to have some sort of discovery for your different services. What if you change the name of that service? There is some sort of coupling between the source and the sink in in this scenario, because if you change the name of the service, you can imagine you would need to change the actual source to reflect the new URI. And this sort of design is the one that we try to stay away from in eventing. So we need to actually work on decoupling the actual sync. In our case, as we said, we are using a URI, and you can imagine if you are using the URI like that, then the implementation of the GitHub source itself would have a piece of code that says if the sync have a URI and it's a valid URI, it's not empty, blah, 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 then my destination URI is gonna be the sync URI. However, I can imagine we know a couple of applications in a couple of objects, a couple of components in Kubernetes that all expose URIs. If you can imagine, and you have, for example, a Knative service, then the Knative service also have a URI. So if I would like to implement a GitHub source that can take the decoupling problem one step further. So we already know that the Knative service exposes a URI in the status. And that means if I would, inside my code of GitHub source controller, say that if the user did not, this logic is more or less correct. It's like 90% close to the reality, but it's not 100% correct. If the URI is not available, however, the user provided a Knative service. So if the sync has a kind that it's a service, and the API group it's a serving knative.dev, etc., then I will add a piece of code that deals with this Knative service. Then my destination URI is going to be a sync.status.address.uri. And you can imagine this code knows exactly the type of the object that is referenced by a sync. So this sync is a Knative service. What if I would like to add another component that includes a URI, that exposes a URI? For example, as you will see later, the brokers in events expose also URIs, because you can send objects, you can send cloud events to brokers. Or what if we would like to implement, for example, a GitHub sync that takes cloud events and calls back the APIs of GitHub somehow? You can imagine then we will keep adding a lot of else-if branches here. Else-if the sync.kind is a broker, the API is eventing.messaging, eventing.knative.dev, etc. And we will keep doing a tight coupling between our syncs and our source, our sources and our sync. So there was basically a very interesting idea about how to solve this problem. And if you think of it from this concept, what is the piece of information that we're interested to find? We're interested in finding the actual URI, regardless of whatever the object is. I don't care if the object is a broker. I don't care if the object that I'm sending events to is a Knative service. As long as it has a URI and it more or less accepts cloud events that is exposed at a specific path, at a specific ports. So then I can communicate with that object without finding out or without actually knowing exactly what is the object that I'm trying to send to, what is the kind of sync I am trying to send my cloud events for. And this reminds us of one of the concepts basically that some of us have learned in different programming languages, which is duct typing. And in duct typing, you basically focus on the behavior. So if I have a service and the behavior of that service is that it have a status and it exposes a URI, and I have a different kind of object, which in this case an in-memory channel, a completely different object, and it has also the same behavior, it exposes a URI, then I have basically a duct type. And a duct type is Knative way of decoupling. Basically, a duct type means that I want to focus on a piece of the behavior of the objects that I'm interacting with inside Kubernetes. And if I can find the piece of information I'm looking for, then I can classify that object after a certain type, which we call a duct type. And you can see here that the piece of information that is common here is the exposure of an address. And this is basically what we define as addressable duct types. So in reality, a sink simply have can have a direct URI or can be an addressable. So if my sink is behaving as an addressable duct type is, then I can basically extract my URI from that sink. And this is the current implementation. The Knative sources basically have addressable sinks. Addressable sinks either expose a URI directly or they expose a URI via the status. This gives you a lot of, this becomes suddenly very powerful because just using a URI, you would not be 100% sure when can you communicate with your service. However, any or Kubernetes objects usually have a readiness. And if you just in your sink reference this object, then your source can check, is this object ready or not? And once it's ready, I can send my cloud events to that sink without actually having a concrete type implementing that different source. So any new object that we're going to have, that we're going to add to our cluster that conforms to this duct type, that exposes a URI as part of the status, I will be able, and conforms to the webhook spec that we also have in our specs, eventing specs, then I will be able as a source to communicate and send my cloud events for. Let's take 1 minute to digest this, and if there are any questions, I'll be happy to answer them.
Nope, nothing as of now. And I also believe like the this particular feature is really powerful to address the sync rather than just giving the plain URI, which obviously like it source can now see whether that particular destination is actually ready. So that is much more powerful than the previous one that you showed.
Yeah, totally agree. All right, so let's dive into some code. I talked a lot, and it's becoming boring. So let's actually do some implementation. And if you want to break down your problem, if you want to do some separation of concerns, then I would like to just start simple. As the first milestone, I would like to install a GitHub source and have some dummy sync that basically receives the events. And from that, I want to see if this piece of functionality work. So let's do that. All right. I can't remember where is there everything. Yeah, all right. So I have my repository. This is the eventers in game. And there was a bit of setup that you can find on the documentation of the GitHub source for setting up the controller and basically setting up using the getting your token and inserting it as a secret, etc., etc. So this part I'm going to skip, and we're just start from a cluster that is ready with a GitHub source controller. So we have a controller, and we would like to start from there. I'm gonna start with 3 namespaces, bear with me. We will gonna like have in our virtual scenario a namespace that is called an integration namespace, and the integration namespace is where I want all my sources to live in. You can think this is a common practice to have from a data point of, for example, having different teams. One team that is focused on the integration, and another team that is focused on the actual in-cluster features. Also, from a security perspective, it is pretty common to have different RBAC rules for different namespaces, because some of these, for example, some of these GitHub sources have different personas that install them. Typically, you would find an administrator who is creating a GitHub source, who's creating a source that is connecting to, I don't know, your enterprise internal GitHub. And this includes some tokens and some API keys that should not be exposed to all the rest of the typical developer who's writing a function and would like to react to events coming from your enterprise GitHub. So more or less, we have an integration namespace where all our sources will live in. And we have 2 different namespaces. One is for dev, where we will do all our work. This is basically where we do all the development and testing. And then we have a prod namespace. This is not to recommend the setup for dev versus prod, please, because it's a big topic to discuss. There are different approaches to do that. We're just doing this for the sake of the demo. The second part is we have a secret, and the secret is addressed from the GitHub source. The GitHub source, as I said, have a set of spec properties. So we would like to react to pull requests and issue comments. This is my repository. This is the access token, and this is my sink. And basically, I'm going to use a very popular kind of sink, which is a very simple container that is addressable. Yes, again, we're going to say that a lot today. So it exposes a URI, and it responds to cloud events and basically dumps them in the log. So let's do that. Let's just focus on ingressing our events. So I'm going to do a lot of hard copy pasting right now. Please don't do this at home. And I'll just apply. Cool. So then I'm gonna watch. Let's quickly get the pods. You can see here that in my integration, I have my. Please hold on. Yeah, maybe this is better. I have my deployment for the source, and this is basically the adapter that is running. And I'm going to have basically just a simple watcher that I would like to keep on the side. Oops. I have my event display, the message dumper that the logs of. Oops. I'm using Stern. Stern is a very cool tool. And you can see that I already have an event. This is because GitHub, by default, sends you a ping event once you set up a webhook. So you can see even right now that we received one event. This is a cloud event. This is the type that it's a ping event. Yeah, this is a dummy event. Nothing actually happened, but GitHub is just sending you the event to make sure that the webhook is working. So at least from a accessibility perspective, it's working. All right, let's do some misbehaving and maybe go to the issues and let's create a new pull request. Basically, I'm gonna edit this and then I'm gonna say Marvel sucks, DC rocks. I'm not sharing my personal opinion, or maybe I am. Cool. Let's see if we have received something. And I'm looking for the clouds. The cloud marks. There it is. This is the second clouds. So this is a pull request event. And this is the source. The subject is 6. This in GitHub, this means that this is the ID of the pull request. All right. You'll see that there's data. And yeah, if you read the documentation of GitHub events, you'll be able to understand more all of these fields, but I'm just interested in pull request. And you will see somewhere over here that this is the body of the pull request itself, just a pull request. There are all different kind of information there. So yeah, that part works very well. So from a first step, I think we have something that is working, which is basically we have a source that is we have a source connected very well to GitHub, getting events, and it's displaying these events very well. Next, I would like to add some features. And if you think about breaking down these features, you can basically think that we have two main features that we're trying to add. We would like or functionalities. We would like to analyze the comments, do some sentiment analysis, figure out whether they are positive or negative, and you want to send an email. So I have basically two small features, two small services that I would like to implement that react to events, and we want to see how we would like to do this implementation. So all right. Basically, what I want to highlight here is I can simply have my implementation as, oh, I have the wrong thing, as a service. And this service implements, let's call this the analyzer, and another service, oh my God, this is the mailer. However, here comes a problem. I would like to have one event and find out or implement the event routing for the analyzer. From there, I would want to get a result and decide whether I want to send an email or not. So one way to do it would be to maybe have a source and then have an analyzer as a sink. But then I would like the result to be sent directly as an email. If I have the email as part of the analyzer itself, that will be easy. But if I would like to break it down, or I have a generic service that is a mailer, then I'm going to have some code that directly communicates with the actual mailer. And this shows that I can actually try to figure out of the problem differently. I would like to think of as a feature, in a general concept, as an analyzer, I have some input, which is some text, and I'm only responsible of one decision, which is figuring out if its sentiment is positive or negative. And as a feature from an email, from a mailer, I have some input, which is also text, and probably some configuration, and I would like to send that text as part of an email. And they shouldn't, as we are doing, they shouldn't be tightly coupled. So I wouldn't really like to have some code that is configuring the sync with the mailer, et cetera, et cetera. So this takes us to a very common pattern in event-driven architecture, which is topology-based event routing. Basically, I would like to have a way to say, take my event from point X, send it to point Y, and take the events that are output from point Y and send it to point Z, and draw my desired. So I have like a building, I have like a set of components or pieces. Each of them implement a specific functionality, and the final solution you can see visually via the topology between these different building blocks. In our case, if I understand that there is a building block or a service that is doing sentiment analysis, and another one that is doing email sending, and I can visually see that I am connecting a source to the analyzer, and the analyzer sending back to the mailer, then I understand more or less the functionality that I'm having. And the topology-based event routing in Knative eventing is implemented by the set of APIs under messaging, which we will discuss. But the building block of this API is Knative channels. This is where we would like to introduce what is a channel. A channel is basically a component that receives cloud events and sends or publishes the set of cloud events to a set of subscribers. It's a very simple concept. We have all came across it. However, we have a bit of extra information that extra features that help you do more sophisticated topology-based event routing with as much decoupling as possible. So, for example, some of the subscriptions can be bidirectional, meaning that you can specify that you would like to route your events from the channel to the subscriber, and you would like the events coming out of the subscriber to be routed to another subscriber, basically. If there are reply events, like some of the subscribers can send back events, and you can decide what you would like to do with these events. So as a concept, it sounds familiar for any event-based systems that we have came across. However, in Knative, it is implemented using the concept that we have discussed before. So a channel is a generic object. You would have a API object that is of kind channel, and more or less this channel information is just where it lives. However, under the hood, you would have some configuration, and the configuration is configuring which concrete implementation of the channel you would like to be created under the hood. I don't want you to focus on all the details. You have the docs there. Just understand that the concept that I'm trying to explain now is that we can, under the hood, decouple the actual eventing technology or messaging technology or persistence technology, and even have them configured, for example, cluster-wide or per namespace. So this piece of configuration is saying, for every generic channel, if it belongs in if it's created in the prod namespace, then under the hood, an object of kind Kafka channel will be created, and this is the spec of that channel. However, in cluster-wide, like else, it's going to be a different kind of channel, which is an in-memory channel. In-memory channel is just a very simple a very simple implementation of the channel that doesn't persist the events, but it just does a fan out of all the events to the subscribers with all the implementation, for example, of retries, etc., etc. This is a kind of setup that is useful if you have if you have like two different kind of eventing systems or persistence, and you would like to have simple ones, whether for cost reasons or for whatever other reasons, that is used for test and development. And once you move to production, you would like to use the actual persistent messaging that you use, for example, in this case, Kafka or whatever. So once you implement that, you will end up with two concrete implementation of the channel. We have an in-memory channel and we have a Kafka channel based on which namespace did you create your channel in. Any questions so far? I'm hoping that... Sorry, go ahead.
Yeah, there was a couple, like what is an adapter, how to create an adapter, but Carlos has explained them well in the chat already.
All right. And by the adapter, this is from the source section, right? We're talking about source adapters.
Yep, source adapters.
Cool. So how does this look under the hood from a control plane and a data plane perspective? Like, how does the channels that we have just seen would... And I think this is going to be a bit repetitive for most of you guys. So this is going to be very similar to some of the concept that we have. We have a controller. So we would like to know if you create, for example, you can create a generic channel object, and you can directly create, for example, a Kafka channel. However, under the hood, they differ. Under the hood, we would like to understand what is happening and how does the data plane look like versus the control plane. So let's focus first on the concrete implementation. So for example, if I'm talking about Kafka, I'm going to try to make it easier this time. Typically, somebody, just like with sources, you would end up with a cluster that had the Kafka channel controller installed, whether by the cluster administrator or you as a developer would use an operator to install that for you. However, there is some controller that is basically the Kafka channel controller. And as a user, you would create a Kafka channel. I'll just use KC. Let me clear this mess a bit. You would create a Kafka channel object, and yes, you guessed it right. The controller would react, and whether same approach, spin up an adapter or a in this case is in Kafka channel implementation, it's a dispatcher, a data plane component that is actually doing the actual data plane communication with Kafka So the controller would make sure that the data plane is up and running, and the data plane would configure itself by communicating with the actual persistent message. So if you have like a Kafka cluster somewhere, you would typically have all the configuration of that Kafka cluster configured once you have installed the actual Kafka controller, or it depends on different implementations of the Kafka channel. But for this one, the administrator took care of that. It installed a Kafka channel controller, and it configured it with all the access information for the Kafka channel, for the Kafka cluster itself. So once the user created the Kafka channel object, then the dispatcher would start communicating and using Kafka. Hold on. And using Kafka APIs to basically, for people who are familiar with Kafka, start the receiver, or we call that producer, Kafka producer. This is the one that basically takes an event and sends it to Kafka. So that's the part about publishing under the hood. If you are using, for example, a concrete implementation that is a Kafka channel, you would get a data plane that knows how to interact with your actual persistent message. And the data plane component would get wired in a way that allows the flow of the event to happen in the way that is declaratively specified in Kubernetes. And how would I, for example, specify that I'm interested in the events that are in this channel as a subscriber? As a subscriber, I create a subscription, and we're gonna look at this later. How if you create a subscription object, then the same data plane would also start communicating with Kafka, so that in this case, it receives events from Kafka side and dispatches the events consequently to your actual subscriber. So this is the second part of the communication, which is how do I get how do I use the APIs of my persistence to actually do the routing? So to try to understand better, let's try to see how does this happen for a very simple implementation also as the in-memory channel very quickly. For in-memory, it's pretty simple. You have an in-memory dispatcher. It's a piece of it's a service that basically gets have a list of what are the subscribers and which channels they belong to. And it receives post requests, which is just like a webhook, receives cloud events, and takes these cloud events and does a very simple dispatching or fanning out to the set of subscribers that it has in memory without any sort of persistence or any sort of using eventing system under the hood. So, for example, if there's like an in-flight request and this pod crashes for some reason before all the events gets persisted, this one is gonna fail. So this is a very simple implementation of a channel, for example. And using this, we would really like to implement our use case. And this is where we want to focus on next. So how do I use a channel to implement my final feature of analyzing and mailing for GitHub comments? And basically, I would use a channel and two subscription, and one subscription. The subscription would be the kind that says, take the events from this channel, send it to the analyzer, and take the responses from the analyzer and send it to the mailer. And definitely that means that as a next step for my application, I'm going to need to take the cloud events from the GitHub source and wire them to the channel and create a subscription to wire to route the events to the analyzer, and the channel automatically will take all the responses and send it to the mailer. So let's try to do that. Are there any comments so far?
Nope.
All right. I wanted to do a time check. How much time do we have?
I mean, we are already over time, but
Yeah, we're over
we should
time.
complete the demo.
Yeah. All right. So let's do this very quickly. I'll just. Oh, sorry. So I'm using Knative functions, and I'll use these to basically, it's a very quick way to implement. I implemented the analyzer and the mailer as simple functions using Knative Func plugin. It's a new component that you will find was recently added to the sort of ecosystem of Knative. The documentation, you will find them online. I'll just quickly deploy these two, and I will also change my source because I would like to have a source now that sends to the channel instead of sending to the dummy event display that we had before. All right. Right now, in this milestone, I have a GitHub source that is referencing a channel. So this is the source, and the sync right now is the channel. So let's deploy all these. And as I said, we have a decoupling, so the function was deployed. So I'm gonna deploy the mailer as well. And I will, in the same time, deploy my channel subscription, then new source, and the subscription will basically point to the analyzer that we have. Just let me. Oh, I keep forgetting here. Actually, yeah. So what do I have here? Right here, I have an analyzer, and I have a mailer GitHub. Let me just make this smaller a bit. Yeah, I have two Knative services, analyzer and a mailer that I need. And at the same time, let's see if I got any channel. Yep, I have a channel that have a URI that the GitHub source should forward that to. How would I know that this is all healthy? I need to check my GitHub source if it's ready. If a GitHub source is ready, that means that the sync is also ready. This is the endgame source that I have. Yep, this is ready. It is pointing to the channel. So it seems that everything is ready. Let's quickly check on the subscription. And the subscription is ready. Subscription, if you're interested, looks like this. I have a subscription that have a subscriber, which is also an addressable, and the reply from there I want to send to the mailer. So I'm subscribing as a subscriber, the analyzer, and the reply events are going to be sent to the mailer. And let's see how that is happening. Probably I feel that we might stop here. So this is the email that would receive. Oh, somebody already sent something. Whoops. So I'm getting a lot of emails from my comments. This really sucks. Whoop. We're gonna. Let me. Check the logs. Whoops. You can see here that I got an event in the mailer that this is the negative sentiment, and you can see that this is a cloud event, and we have actually sent that email. So if I just need to refresh, negative comment found. Hi, this is your friendly GitHub moderator. I just spotted what seems like a negative comment. If I click on it, this is the comment that we just posted. This really sucks. However, if I post a normal comment, actually, this is not so bad. Actually, this is great. I don't know how Azure sentiment analysis is going to pick up this. So you will see that I'm not going to get an email right now. There's the event, and the sentiment is positive. I'm dumping the mailer, by the way. So this is the events that I'm getting from the analyzer, and there are no emails that were sent. So if I go here, I'm not gonna have any sort of emails. We just have our regular pull request events getting sent to us right now. All right. So I'm not sure time-wise if we can continue or not, but basically that's what we did so far. Is we use the channel and the subscription to route the events from GitHub source to the analyzer, and the replies from the analyzers are getting sent to the mailer. The cloud events from the analyzer have the sentiment, and this is once it's a negative, then the mailer will actually send it out. Cyan, how would you like to do this?
Yep. So how much content is left? Like
I only have a small change using the broker, so we can skip the under the hood details and see what does the broker do for us. It will take about 5 minutes.
Yep, let's do it.
Cool. So you will see that using this implementation, the mailer got both events, the positive and the negative, if you've seen the logs. So that means for let's say a very popular a very popular repository that it would receive a lot of events for no real use or for no real value. I would like to actually receive the negative only, and that means that everything in the channel I'm gonna get anyway, because I cannot specify what kind of events the channel is receiving that I would like to filter and receive. And this is basically the use case of content-based event routing. Knative does that by the broker API or the eventing APIs. The eventing APIs allow you to specify to have a broker. The broker is also a component that receives cloud events. However, the subscriber uses triggers instead of subscriptions to specify an interest, and the triggers can have filters, and this is where it makes a difference. The filters, if you would like to see them, allows you to specify cloud event attributes. So this is a trigger that have a filter, and using these attributes, you would actually receive only the events that are matching our attributes. And that means that simply in our application, we would implement that by having the analyzer with a trigger, and the trigger is interested in the GitHub issue comments cloud events. So I would not even receive any pull request cloud events. And the mailer would be interested in the negative comments only. So the cloud events that match that. And basically, if you would like to see this in action, what we will do right now is delete everything that we have from here and deploy our broker and our triggers. So a broker was created. I have two triggers, and right now my GitHub source is referencing a broker. So GitHub source. Sources now have a sink, which is the broker, as you can see. And the two triggers, one of them has a subscriber URI, which is the analyzer, and the other have the mailer. Let's quickly look at the mailer. You see that it has a filter which says, I would like to match the sentiment that are negative only, and the cloud event type that is sentiment. So right now, we still have our log that is happening. On the left, this is the stern for logging the mailer, and this picked up the new mailer already. Let's go create some comments. This is a very bad demo. So we're gonna see what did mailer, wait for it. Yeah, you need to know that I'm using, there it is, K services, and K services were configured by default by a very small scale to 0. So yeah, I actually got cloud events, and the cloud event have a negative sentiment there, sentiment negative, and the email was sent. So I need to check out, did I get any emails? Carlos is here. There we go. Comments. This is a very bad demo. Yoo-hoo. So yeah, I got my email. However, let's test this with actually, it's very cool. This is a positive one. And see, oop, I don't have any cloud events. And to make sure, that's not the cloud events. This is just errors from the key proxy. Make sure that -c user container. Just give it a sec. There, we only have one cloud event that we received. And to make sure that actually the analyzer received it, then we need to, yeah, look at the analyzer. We have two events. I'm sorry, they're very long, but basically there they are. We have two events that we got in the analyzer. The other one was very cool. This is positive. We sent it back, but it did not reach our mailer because of content-based filtering. So what I'm actually interested for is to tell you, please join our eventing community. All these great features were delivered to you by great folks in the eventing working group and the other eventing related working groups. We have 3 eventing working groups right now. One that is focused on the sources, another one that is focused on a delivery of eventing inside Knative, and the umbrella Knative eventing working group is the eventing working group. Check it out. If you have any questions, we are available on Slack, and we would really like if users and or contributors would join us in our new discovery for what is beyond V1, because we're going to release Knative V1 at some point, and we're very interested in finding out how eventing helps you and what do you want extra after V1. That's it, and sorry for taking longer of your time.
It's completely fine. Actually, that's what we were discussing the chat as well. So that's actually a deep dive session on when we say it's a deep dive session. So obviously it took more time, but it was going super interesting mode. So we had different milestones that we wanted to achieve. First, we had only the demo sync. Then we had the actual channels where we had the target, and we were able to send from the analyzer, we were able to send the events, and then we were able to get from in the mailer both the positive and the negative, but it was sending to both. And then we had added the filters in the last section, where we only picked up the negative events for the mailer and no other kind of events such as pull requests and all sorts of things. So I think that was the flow was really good, and seeing it in action was really good, and breaking down of the concepts were really good. So thank you for that. Just before we leave, I want to give a shout out to Rashmi Bala Mohapatra for writing the Twitter threads for each of the stream in a very dedicated manner. So kudos to you, and just reach out to me on Twitter, and I'll give you a special swag from CNCF store. So it will be a $30 coupon that you can redeem against any of the swags which are there on store.cncf.io. So just reach out to me, and I hope you learned a lot during these 4 streams. I have seen your Twitter thread, so I am thinking that you must have learned something new. And yeah, Carlos has one comment like, now I see how Ahmed ignores my emails. Okay. So and thank you, Carlos, for supporting in the chat, answering all the questions. So a big shout out to Carlos as well. And once again, thank you, Ahmed, for spending your extra time on a vacation for explaining all these concepts. So that really appreciate that.
Yeah, it was really fun. It was my pleasure. Thank you very much.
Yep. And lastly, please do not forget to subscribe to the channel. And there are lots and lots more streams coming up. You can see in the upcoming streams. So next full month will be a series of lots and lots of good concepts and tools and technologies in the cloud native ecosystem. I'm excited about it, and I hope you are too. And this Knative series, share the playlist with everyone so that people know, people can use Knative, in a good way, and they can get more involved in the community and drive that more. And yeah, happy weekend, everyone, and have a good day. Bye.
Thank you. Bye bye.